Your voice is
What we
skip low.
discussed yesterday, that is
I think Anand
obviously,
Vikram has some question.
yeah, please go ahead.
Anand, can you hear me?
Sorry, you, yeah,
Anand, can you hear me?
yes, yes, yes,
Anand, I just had a few questions, some very
sure,
general questions, because yesterday in the evening I was thinking about whatever we
yes,
discussed yesterday's session.
sure,
Just want to relate it to, for example, what we do in in legal contracts, where we talk about extracting, let's say, for example, clauses, obligations, risks, or where we talk about generating some uh, insights. Is all of that also ultimately it's just boiling down to this concept of perceptrons? Is that what you're trying?
Ev- everything, Vikram, everything is perceptron. Now, basically, I do understand that it might come as a shock to a lot of people. Now, you guys can just go to chat gpt and everything and do the back research also. So the point being that every all of the deep learning is based on arrangements of perceptron. Now these perceptron behave in a way that they can learn a lot of things, and then they have their own like limitations. But yes, as of now, this is what is happening behind the scene. And we will see today, even we have an example to cover. So we'll see arrangement of all of these perceptrons, and we'll see how they behave.
Okay. Okay. Thank you.
Hey, Anand, I have a question regarding the same on perceptron.
Yes,
So
please.
in perceptron, how the bias decide to that input and output actually? What exactly, uh, like weight I can understand, but how
Correct.
exactly like bias can decide this? How we can give that
Sorry,
to?
are you asking bias?
Yeah, there is a in the, if you can open that PDF, right? In the perceptron, we have an input, we have a weights, right, and output. But I
Right.
can see the bias also that has mentioned. So what exactly here that bias is means?
Sure, sure, sure. I'll go to our PPT that we had been discussing. This was our perceptron PPT. Now, basically, what is happening? I'll click here a new one. Now, let's say this is again my perceptron, right? Sorry for the bad drawing. Now, ideally, what happens is we stack these perceptron in a layer. We call it layer. Right? This is my layer. In this layer, basically, I will be having few perceptron. Now, let's say my first layer can have as many as number of inputs that I want. Let's say for housing, I have inputs such as a number of bedrooms, right? Number of bedrooms. Then I can have input as uh, area, then locality. And locality means here everything is number. This one is number, area is number. Locality also has to be a number. You can actually grade the locality out of 1 to 10 and then do things like that. And then one more thing we can take is amenities, number of amenities. So ideally, amenities you can grade out of 1 to 10, or if you want, you can prepare a matrix that it has swimming pool 1, or it has clubhouse 0. So these kind of input. Today we'll discuss basics of some of these things. Now amenities it is taking now. There will be basically this will happen. This is layer 1, right? Each of these perceptron or each of these neurons, what we usually call, right? We actually they will take the input, and then there are multiple mid layers in the model. So it can have, this is L1, and you can take L2 to L10, right? I mean there are 8 mid layers. we call them mid layers. We also configure that how many perceptrons we want in each of the layers, let's say in L2, L3, L4, and L5. We can choose that we can have 10 perceptrons here, we can have 12, 13, 14, but usually then we have an output layer. An output, what you want is, you want what should be the tentative price based on like all of the housing, all of the pricing that have been placed, right? So usually either you want one perceptron in the end that will contain the output, right? Or if you have 2 to 3 outputs also, basically we can have 2, but last layer usually have limited number of perceptrons, or we call it usually the output layer. And now what is happening, this data will go here, all of these perceptrons, they are going to communicate with each other, and then in the end, when the weights are optimized, right, they will ideally come down to this, and in the end this is what we get. So your question is very genuine, because any newcomer will usually get confused that how many number of inputs we have to take, how many number of outputs do we have to take. This we will learn also, and you will also have to play. I mean, building your model. I'll give simple things wherein you can build your model and you can play around. So this is how you can actually take it. Now, this whole science of weight, whatever you call it, weight management, you want to call it with a new name or something. Now, this is like, it comes as a, surprise that we have been solving problems otherwise, and how is this that even problems can be solved using this method, but it works. You recently might have heard the CEO of Anthropic saying that I do not know, and nobody knows. He said that CEO said that nobody knows how AI works inside. Right? Now, basically, what the point is, it actually works like a magic. But what is happening when you have a lot of billions of here? Now, when I talk is billions, this recent version of ChatGPT is around 100 billion plus model, not 1 billion, 100 billion. Now, it is impossible to influence. We can influence a bit, but we cannot control these whole neurons. Now, weights means, since they are talking about 100 billion parameters, sorry. When they talk about parameters is weights plus biases, right? Weights, what we have in the here in the single neuron, when we talk, we get the input, we have weights, and we have bias, and then we have a firing function that it simply decides if we need to decide that this whole neuron should be considered or its a value we should ignore. Basically, step function, it is called the step function.
Is that the same as activation function?
Yes, it is same as activation. This is activation function. I'm just simplifying the term. This is an activation function. So it decides if this neuron should be activated or not. Now, there are certain parameters on which we can decide if this neuron can be activated or not. So does this actually solve some of the doubts that you have in your mind? Because a lot of things, when we see them in the practical, we will understand it better. But yes, this new science of arranging the weights and solving any problem, this is somewhat magical, and humanity accidentally discovered it, right? And we are utilizing to the best, but it has limitations. And in future, we have like lot of scope about it. I also discussed like what are the things that are going to change in future, you know. So Keo, is the doubt clear?
Yes, Anand, thanks. I have a few doubts, but we will talk more on the practical session. So if I
Sure,
do
sure,
not have a clarity more on this, we can discuss more on that part.
sure,
Thanks, Anand.
sure, sure, sure. All
Anand,
right.
one more question from me.
Yeah,
Yesterday, you said that because all of deep learning today is based on pattern recognition,
correct,
uh, and hence you said that it is not possible for it to be 100% accurate. Can
correct.
you just explain that a little more? Like, why is that so?
Sure, I'll come back to it. Now, basically, the whole point being, see, what happens usually is what we do is we have problem number one, that we can influence the model, we cannot control it as of now, right? Inside of the model, we know that it is perceptron, but billions of these values, and for every query, uh, this specific perceptron is going to behave in a different way. I'll show you a demonstration. Let's say you have query one, or consider it problem one. Now, what might happen in this case? This perceptron might fire, this might fire, and this might fire, right? So basically, for this problem, only these of the perceptrons are going to fire. However, when we have query Q2, right? In that case, now we have query Q2. In that case, a different set of perceptrons are going to fire, right? This combination. So it is a huge amount of permutation and combination that actually makes this pattern possible. And we think that this is a kind of logic. Now, since we do not, inside of the model is still a black box, so what happens many a times that we keep on training the model, we keep on training, but it has a limit that some things it will forget, and some things it will like it will add to the knowledge. Now, covering all of the use cases, when the use cases is huge, it becomes very difficult, and hence we are struggling with all of the AGI stuff and all. Even the code, even if you generate all of the code and everything, right, you will see that sometimes the AI struggles with very simple form of code. Sometimes this AI is struggling with very simple codes. However, sometimes the very complex codes it is able to output you. That is basically kind of cramming. They're big size parrots, huge size inside memories. So this being the reason that since we are not able to control them, as of now, pattern recognition can maximum, I mean, lot of use cases, when we add, it forgets it. So this forgetfulness is again one problem that we are still researching on. Second problem is hallucination, that it very confidently produces information that it does not knows. And this again contributes the whole basic system that, every neuron down the line is basically, it's a linear function. Actually, this I1 into W1 plus I2 into W2, all of this is actually kind of linear function that originate from y is equal to mx plus c. You don't need to confuse with this, but that's okay. So the basic nature of neuron being, we are not able to control them. We can influence them a bit, but sometimes we add the information, it forgets. So all of this is completely happening at the same time. So the solution that these guys have come up with will add more models. We'll keep on adding models, smaller models that are specialized. Hello. right? It is MOE models. Usually we call them MOE models, mixture of experts. The mixture of experts means basically all of these expert models, basically they combine a lot of these models, and this specializes in task T1, this specializes in task T2, this specializes in task 3. And then we combine all of these models and produce the output. So I hope some part of this is answered, Vikram.
Yeah. So can we say that the fact that this model has a tendency to forget some of its learning or produce hallucinations, those can be considered as drawbacks of deep learning as of today?
Yes, that is one drawback. The other point being, there are some patterns that are so complex that it doesn't learn. Or we can say that some of the patterns, like data labeling, since past 3 years, all of the progress that we have made is not through the architecture, how much data we label. Now, this is where we are also coming to an end, that labeling the data as per the complete logical thing, it is a very tedious task. So there we are actually coming to like all of these OpenAI and Anthropic. This is where they're concentrating that we need to inject more labeled data, more reasoning type data. That is, we teach them step-by-step reasoning. So they learn this pattern. And then, okay, this is learned, then we teach them mathematical patterns. So it is point being teaching them patterns one by one. Only what is being injected into them, only that can be produced as output. As a result, a lot of times human mind works differently. I mean, you have pattern 1, pattern 2. Out of those 2 patterns, human mind will produce another 1,000 patterns itself. This is what real intelligence is. And here you might have fed into 100 patterns, but it might remember at max, the model is very good, it will remember 90 patterns or something. Sorry. The model will remember some 90 patterns or something like that. And it will forget some, I mean, out of 100, it will forget some patterns and do all sort of things. Yeah, is it any clear now?
Yeah, but one thing that I'm still trying to try to figure out is, like, when you're saying that the model will forget a pattern,
Right.
I don't understand what does that mean and how? Like, what do you mean by forgetting a pattern? Like, because
Yeah, ideally what happens is, okay, I'll explain with an example. Now, basically what happens.
because I was trying to understand that the model is like a huge database of all the patterns, where it might be storing all the patterns.
Yeah. How does it stores? We do not know.
Okay.
Now, let me tell you a very simple example. Now, till date, what is happening is, I gave you that pattern P1 you have been learning since like childhood, that, okay, if this is a graph and you need to, this is your graph that you have been given, and you need to predict this line, or line can be anything else. It can be this. So you need to predict this line. So what you can do is you need to have this equation, right? And this equation, by feeding this equation, you will come to a solution. This is pattern 1. However, now we come with pattern 2. That pattern 2 says that, you know what, you just input the data to these perceptrons, and these weights will adjust, and you will get automatically, it will automatically learn any of these equations. It may be equation 1 or it may be equation 2. It will automatically learn it. You don't need to take the overhead. All you need to do is just need to give the input data. So then this P2 and P1, if you see, they're mixing together in a way. I mean, this P1 is saying this comes with a different theory, and it comes with a different hypothesis and everything. Whereas this one comes with a different theory and different hypothesis altogether. As a result, when I try to teach both of these models, I have to come up with a lot of examples and everything. And when I put a lot of thousands of patterns into it, some of these patterns might overlap, and these neurons, like the learning of these neurons, might get disrupted. The whole point being, let's say there is some neuron, let's say neuron N1, N2, and N3 inside the memory, and we do something unknowingly. I mean, since we are not able to see as of now, means we do not know that these uh, neurons are responsible for this knowledge or this solution.
Okay.
And hence we might add some information that disrupts the learning of these neurons, or you can consider them as pathways. Like these are neurons, and these are various neurons stacked together. This is solution 1, this is solution 2, and this might be the solution 3, right? This might be solution 3, solution 2, solution 1. Now you inject any new training, and this pathway gets disrupted. It is forming some new pathway. This pathway, it is forming this kind of pathway, right? So the previous one gets disrupted, and we have no idea, because there are so many paths, there are so many patterns. As of now, we do not have any idea or control over it.
Okay, this makes sense. So that means you're saying that the more a particular model is trained, it's going to create these maybe millions of pathways potentially,
Exactly, right.
and that can cause a particular pathway which was already learned from a previous training session. Some of those might kind of get overwritten, or
Exactly, right.
even if
Because
even if one neuron gets disrupted in that entire pathway, the entire pathway is gone.
and that starts with the hallucination problem. I mean, it starts spitting out something that it was not trained to do for. I mean,
Okay.
half pathway it is picking up from somewhere, half pathway it is picking up from somewhere. So these kind of things. So the whole point being, there are so many permutation and combinations happening here that for human it becomes impossible to judge what is happening.
Because we are only providing the inputs. We are not actually controlling how it connects those neurons and creates that pathway.
We have no control over it.
Got
Right. In future, down the line, after 10 years or 15 years or maybe 20, 25 years, we might be able to do it. Then, see, the other problem that exists is that, let's say we have a huge model, large language model, LLM model. And this LLM model, what it is saying, that it is some 100 billion model. Now you want that, I just want the contracts part. And there is some healthcare company, it says that I just want the healthcare part. So this is an active research, but no success so far, that you just copy that learning paths that concern your contracts part or legal part, right? And you just, this is 1 billion model you created out of that. Now this 1 billion model you can even run on your system. It is super cheap and everything. But as of now, what is happening, even for utilizing this small part, you have to utilize this whole model. And same goes for any other use case.
Okay. Because you don't know which neuron or which neurons are participating in the contract part and which are participating in the healthcare part. There is no way
Exactly.
that you can know that.
There is no way.
You cannot extract as part of this LLM for a special.
No, we cannot.
Okay. So what is
We are
it?
doing,
LLM and a small language model.
yeah. So basically what we do, LLM and small language model, right? Now, small language model, basically, as of now, what we do is we extract all of the text information, that is outputs, and then we feed those outputs into this SLM. So we cannot directly transfer the learning from this to this. We'll have to take this part, like we need to extract the output, and this is what DeepSeek and everyone has done. What they have done is they purchase this ChatGPT subscription, and then they hit it in and out day and night. They collected all of the responses, and then they fed that response into their own model. As a result, when you go and ask DeepSeek, what is your name? It will say, I am ChatGPT.
Oh.
Yeah.
Oh, okay. So small language model is not like a subset of a large language model.
It is not subset. It is a small model. Like it will be 100 billion model. This might be 1 billion to 2-3 billion, right? And this is what we have been doing, Vikram, even in previous organizations. So in my experience, I have been training small language models. I mean, all of when we work together in previous organizations,
Yeah, yeah.
this is what I did.
Okay.
Clear?
Yeah, yeah.
Cool. All right. So we had done all of that. And now it's time to even explore further on these topic itself. Now, the power of connecting dots. We will be further exploring this science, this wonderful science of uh, and what it can do. Its uh, influence in everyone's life has been tremendous. So a general theory that I believe is, just give me a second. Okay. General theory is that uh, anyone who has discovered in any market, that is any space, who have been able to discover a specialized pattern has found his way to be a millionaire. When we pick up any past examples, like uh, anyone, all of them had a very strong analytical skills. Right from some people, like while buying the stocks, they used to go to dustbin and of the whole city to see that what products are being used most. So to some people working on the paper, all of them had very strong analytical skills. However, uh, sometimes you might accidentally discover it, and sometimes we will have to force discover them. So this is the whole point. Even in sales and marketing, uh, we get with lot of numbers. Out of those numbers, we have to pick up that, okay, this is the path that I guess no one is noticing right now, and I can just pick it up. Or it can be in finance, it can be in your career path, or anything. I mean, this applies to everything. I'll just start with a small example. In around 19, so this example is of 1850, sorry, because in 1950 this science was developed. Basically, there was a cholera breakout in a city, and this is a real story. Basically, there was a cholera breakout in the city, and at that time, medicines were not very developed, and people were dying. There was no idea. uh, there were rumors all around that it is airborne, just like a virus, and people are dying just by maybe when you are in their vicinity. If you breathe the same air, you're about to die. However, there was one smart guy who came, called as Dr. Snow. So the first thing that he did was he prepared all of the data. I mean, a hard work. This is the most hardest part, in any problem. We might be thinking that, okay, we are learning AI, but this will be the most hardest part. But no, the first harder part is the data. Obviously, the second part is the analysis and analytics, right? That is predicting the future and basically finding the patterns in it. The whole AI is around analysis and analytics only, right? Now, what he did was he prepared all of these like various sources of data, that from where you have, and this included very, if you go and uh, read this case study online, I mean, this is in very detail, that on what location are you there, what was the water source, I mean, from where have you been drinking water or filling your water, from where you have been purchasing your food, and where did you have your last 8 or 9 foods, did you attend any gathering, and like how many days since the symptoms you are facing. And he prepared all of this data and he plotted all of this data. As a result, after much of the analysis, I mean, there was no medicine at that time. So after much of the analysis, what he came up with is that, okay, these people who have been drinking water from source A are mostly ill, right? And he came up with these kind of analysis, or we can say the clustering of data, whereas the people who are away from this water source have not been ill, right? So he came up with all this analysis, and basically what they did is, after they took some steps to basically ban those water areas, as a result, the people deaths declined eventually. This was the first case study of like how to use analysis in these kind of situations, epidemics and everything. This not just came I mean, this after this, the whole science of analysis and analytics, it became started developing. We started developing all of this science more rapidly. As a result, what happens that they named this science after this epidemiology, right? And key observations, what they observed was, they said that visualization of the visualization and outbreak. They said that, okay, map shows city districts and water source locations, identifying the pattern. Again, we come up with a pattern, significant clusters of cholera cases in the North District, pinpointing suspect sources, that well A and all of these things, comparison with other areas. And then basically he started plotting this data. That is, visualization is very important. Right? Because this is the actually source of all of the dashboards that we prepare in our softwares. And this is the whole point, that you look at it once and you're done. However, then dashboards also like span across, that you should be able to show some kind of predictions, right? And then the map through fictional mirrors real image, and then so this is a kind of investigative field, but this data, or this gold analysis that we prepare from all of these things, is pure gold. This can change companies' fate. This can change people's fate and everything. But however, as you want to start with any of such field, make sure you have the data, or you have enough money to collect the data, because data is costly. Even after you have data, it is going to take for cracking any big problem. It may be, let's say, you're trying to do any disease detection or anything. It is going to take you around 1.5 to 2 years to crack, to solution the whole problem, research and everything. But if data is also not there, then you will be stuck, and you will be stuck even badly. Or we have the money to, collect the data. So always, while choosing the problem, this is very important. One more small example I want to take. This is the problem of Jim Simmons. And he opened a company called Renaissance Technologies, right? Basically, what he was an investor. So what he did was, he said that, okay, I will crack the market in a different way. I mean, his history was in analytics only, and he used to do this analytics for defense. He did it like for World War II and everything. And then what he did was, he collected the people who knew maths and physics and everything, who are code breakers, who used to solve patterns and puzzles. I mean, all those people. And then he started basically, even the points that you would even miss, that obviously news is one thing, then reaction of people, the sale of individual items in the market, right? Inflation and all of these. He prepared huge number of like 200, 300 parameters list, and he started his analysis on that. And surprisingly, he discovered the patterns that no one was able to discover. which made him a lot of money. I mean, millionaires. And all of the people, many of the people that we see, people have been able to crack their path into billionaires and everything. And so one question you might say, if you know this much, then why are you not doing it? So I am also in the same pursuit, to be very frank, right? I have spent few months and years in one problem, and I hope that I will find some golden pattern. But yes, I mean, it happens. And at one point of time, even the problems that I have been researching on, I also felt that, oh, this is not going to work out. But then you start going through that process again and again, spending hours and hours on that. And then you see that, yes, you have some information that others people are not having. And once you have that small delta, extra information, that extra intelligence, there you go on, right? Good. Any doubts on it? Although we have not covered any substantial theory till now. Great, everyone. Right. Now, what are the applications of this pattern finding? This pattern finding is in every field. You pick up any field, medicine, finance, astronomy, climates, NLP, big application we already saying, that is these large language models. In security, retail and commerce, manufacturing, epidemiology. Now, basically, this science has advanced so much. I mean, that even when you look at an ad, right, there is a specific research being done, and that also they collect the data, that there are specific labs there, that when you see an ad, what kind of response or how your brain behaves. And thus we have all of the applications that you crave to use, or you sometimes crave to spend, and all of those things. So all of these companies like Mintra, and these kids videos, so they specifically have these kind of analysis going on, these kind of patterns, that okay, this is where the attention of a kid drops, so do something here that the attention is again picked up again. Same goes for all of the fields, especially this advertisement field has done a huge amount of job in this, so that you crave for buying that product. Everything, it has been arranged in such a way that ends up you buying something that you do not even require, or some kind of, and this science includes everything, psychology and everything. Now, this being the whole point, that data is important here. We do not have data, we'll not be able to understand all of those things. Now, what are the traditional ways to find these patterns? Traditional ways, there are a lot of this field evolved, and traditional ways were developed. Like, first we used to develop visual inspection, and then just the way the cholera whole case study was there, and then you can have like mean, median, and standard deviation, and you can do all sort of statistics in that. And then basically the end of the day, you need to find the relation between the various parameters. This is the whole maths around everything. You have various parameters. Now your parameters are basically your inputs, right? In a lot of different cases, let's say you are analyzing any, when in housing problem, then your inputs are different, right? And let's say when it's climate problem, your inputs will be different, and all of those inputs become your first and foremost thing, the parameters kind of thing. Although in technical terms the parameter is different, but just for making you understand. Now all of those, basically we call them variables, right? So all of those variables we have, and the whole theory is about finding the relationship between those variables. Now obviously human mind usually sees only the variable that our brain can detect in a very short amount of time, but there are patterns so complex that are just impossible for us to detect. I mean, even after churning day and night, there are some patterns that surface out, and all of these things happen. So yeah, I mean, there is a specific companies doing this, just these kind of jobs for companies. There are some companies that trust them, this whole process. There are some companies they're still not trusting this whole process, because obviously all of these things, and someone saying that, you do not trust your intellect, you trust all of these things. Some people feel that your data always speaks the correct story. It is not your intuition, right? Intuition always deceives you, and the data is something that will always speak the correct story. Your intuition, your brain always says, no, this is what I feel is right, this is what I feel is right, but it is not backed by any proper methodology. And then we have the hypothesis testing. Once we have developed all of this analysis, then we used to do the hypothesis testing. Huge amount of education required for doing all these things. And then, but then came this deep learning, that is the whole game of weights and biases, and everything changed. Weights and biases said, I am a black box, you give me an input, you get an output. Forget about all of this science, I learn myself, right? And this is where the magic begins. So basically what it did is it just threw away a lot of old statisticians. But yes, I mean, this is not true. There are a lot of places where even they are doing this job, and there are certain advantages of doing that, and there are certain disadvantages of using deep learning, but we'll discuss it, right? The whole point being how efficiently we are using any of these tools. Now, here in all of this, there is one important point, and that is regression. The word is very fancy, but its meaning is not really that fancy. The meaning is simple, that relationship. The meaning is simple. This is what regression usually means, right? Actually, regression means, if you go and check out in the dictionary, it means converging back to mean. That is, there is one golden hypothesis that word runs on, basically, from which this whole theory derived, that anything in this word, right, when it usually works on a middle path. As Gautam Buddha said, that select the middle path, that anything that goes to extreme will return to its average path. And you see this anywhere. Mean means extreme. This is extreme high, extreme. Sorry, actually I draw the wrong. So it should be like this. So this is, if let's say this is median, and if anything goes here, extreme high, extreme low, it will also return here. This is also bound to return here. So basically, this was the point of that. It will regress to its mean path. But however, with statistics, as it advanced, this changed. Basically, this whole study became, how do you find the relationship between various variables? How to find relationship. This is the whole study, and this is what we call regression. This is what we call regression analysis. Right? Not any complex term, just a simple term. Now, you can use regressions anywhere in your communication, but just a small joke here, just to break the ice, that two people discussing why did you break up, and the girl is saying, because our relationship had no regression, right? That is because, I mean, no regression, that is both of them were not changing as per, that is one variable was going somewhere, the other was going somewhere else, and thus it did not end well, right? So we talk more about regression, because from regression itself we will go to other topics, but this is because the whole AI word, like I have already discussed also, the AI is basically revolving around two things. First is like analysis, then we have analytics. Now in analysis, we can have a lot of things like we have data, right? We are extracting some information out of it. We are extracting some information. And analytics, we are forecasting something. Now, I mean, since the advent of generative AI, we have started generating also information. We have started generating information. But again, this will also be like it kind of performs analysis itself, because you have your given data, and from that it will pull out maybe some information. It will answer you in that, I mean, in whatever the context it knows. So it is basically grooming or transforming the information. Like we can also say that the information is transforming from one form to another format, right? And then we are performing analysis, then we are performing analytics, forecasting. Forecasting is still a tough nut. If whatever the companies have done good job in forecasting, I mean, they are on next level, but there are very few companies who are able to do the forecasting. And forecasting is still one of the very important business use cases that has not been cracked yet. Analysis is fine. I mean, pattern finding still. So this is a kind of smaller area wherein all of the AI, and there are multiple use cases then coming out of it. We'll also have a look at, but this is just a small version of it. Now, understanding regression analysis is basically very simple, that we can have two variables, we can have multiple variables, right? It can be and multiple variables, v1, v2, v3, and v4. Finding how one variable is changing with respect to other, right? This is the key of regression analysis. We can have multiple variables, we can have one, two, or more variables, right? It is a statistical method to find how variables are related. It helps predict how much one variable might change if another one does, right? And you see a lot of applications around the same thing. Let's say the gold price is changing, the inflation changing as per the oil, Indian stock market changing as per the other market, right? So regression helps you identify if a relationship at all exists and what is the strength of this relationship, right? You take any basic example. So basically, most of the time we will be trying to find out that what is the relationship, even with the words also, even in the sentence. What is happening that when we are having any sentence, earlier we used to do this, I mean, after this generative AI and all, earlier we used to study sentences. Let's say there is a sentence and we used to study sentence that, okay, there is word one, hello, how are you? Now then, basically, if how and are present together along with you, then it might have different sentiment altogether, right? It might have a different sentiment, and sentiment one, that is like requester sentiment or angry or happy. We'll have one example on this. There is one example awaiting on this thing also, how easily this can be cracked down. Right? Now, just coming to regression part again, just this is for understanding. However, do not think that when we go, we'll have to remember all of these equations. Then obviously the point of deep learning is not making sense. We will be telling this black box to learn all of this information based on the data. It will learn this information and it will give us output, right? You can go ahead. I mean, whenever we want that we have lower budget, or we have like a small regression program is very lightweight, many times customers do not understand that we need this problem or not. So we can give them any of these linear or polynomial regression simple problems, coded in a simple way. No fancy models required, no GPUs required, nothing required, right? So it depends really. If these are very lightweight solutions, they do not require any GPUs. But yes, someone should have a proper understanding of at least basic plain mathematics, and then they can be cracked up. However, if you want to do it through deep learning, then also simple deep learning models will be able to do it very well. Nowadays, if you see uh, some of these models that can be made in KB, people are doing these kind of linear regression also from ChatGPT and stuff like that. I mean, this is basically you are using it for some other purpose. It was not meant for. So linear, as the name says, it's a straight line. Polynomial, as the name says, the curved line, right? And logistic regression, basically, logistic is basically finding or separating different dots, in the sense data types. It can be your IMDb comments. Now IMDb comments, it can be hate comment, or like good, angry. So this also comes into logistic regression. That is basically we are trying to differentiate between the data type. We try to differentiate that this is type A. Automatically it is able to differentiate this is type A, this is type B, this is type C. Polynomial regression, very useful. Useful in scenarios, when not every time my data is going to be in this plain line format. Many a times it will have this kind of this thing. So then in that case, I can use this polynomial regression. I can find the relationship that, okay, this is here. And although it usually works with simple curves only, when complex curves, the real data is usually not even like this, not even like this. This might be the place, but usually the data is like this. This is how the data will be. It can be sentiments, comments, or anything. I mean, the data is not very structured. Right? So what do we do in that case? So these are simple cases like linear and polynomial regression, logistic regression. However, not to underestimate linear and polynomial regression and logistic regression. These still solve a lot of problems. These includes for known application approval. Internally, they are still using logistic regression based on your like all of the credit score and everything. These are live applications, right? In insurance, these are used, right? In deciding if this customer is an ideal fit or not, these are used still in many places. In fact, these are still used in most of the places. However, when you go into the market and you see, you will actually find out that 70% of the problems are being solved. 70, really, this is a huge number. 70% of the problems are being solved using these three, but you just need to know how to apply them properly. I mean, just these three types of regression, they are able to solve 70% of the intelligence problem and everything, right? We will come to this point. We'll see how we will do in our very own way in simplest format. Coming to further point, that the whole point being finding patterns again and again, right? We have few more algorithms. This is the old way, right? Or we can say non-deep learning way. Non-deep learning way. So deep learning is anything that is using neurons. That is, perceptrons and neurons are interchangeable terms. Right? Anything that is using machine learning algorithms for finding patterns, these are called as neurons. It is called as non-deep learning And in non-deep learning, we have a lot of algorithms. We have like regression algorithm, we have decision tree, we have random forest and ensemble methods. Ensemble means mix. So not to be afraid of this fancy vocabulary. It means a mix, right? Then if you want to go for clustering algorithms, you can group similar algorithms together. Clustering means, let's say, uh, like these are kind of data, right? And this is one more kind of data. So basically, you get to know that, okay, this data type is similar, or this data type is similar. So this might behave same, and this also might behave same. It can be as simple as that grouping the data based on symptoms. You know, sometimes these are very simple. I mean, you can do it in Excel, but beyond Excel, obviously, you'll have to use these. I mean, these things when you're trying to do. And then you have clustering algorithms, you have dimensionality reduction, and you have association of rule mining and everything, a lot of things. But then, you know what? Then we learn deep learning, right? So two guys discussing that, you know what, I have regression, I have XGBoost, I have random forest decision tree. What do you have? How are you going to solve these problems? And the other guy said, I just need deep learning. I just need one tool and all of these things get covered. Right. So in many terms, all this thing is also termed as machine learning, or this is basically old way of machine learning, right? And this is deep learning. Deep learning, basically, when we build the models, we build the neurons, that is deep learning. Right. Any doubts, guys? Everything is clear? Cool. All right. Right. And then even Buddha used to say that deep learning solves all of your problems. You know, so we should trust Buddha, right? So now, traditional machine learning approaches and one deep learning, you know, so now slowly you would had started to understand that all of these algorithms, now please don't consider me saying that these algorithms are useless. No, not at all. These algorithms take time to study, but they have a different kind of advantage. First and foremost thing, these are very lightweight. That is no GPU needed, or even some higher algorithms like decision tree, like XGBoost and all the some of these decision tree random forests may use GPU, but most of the time they will be able to learn through, I mean, in CPU model itself. Now they can learn through complex patterns, but up to a certain extent. I mean, when the data is too complex and everything, some of them actually lose their credibility. Accuracy gets reduced. But yes, I mean, for a lot of the problems that we see around for forecasting, for relationship finding, recommendations, even since we are here, so all of the legal framework before 2018 was based on left-hand side models only. Legal frameworks, when I say that, I mean, we have been like I have been working extensively on clause extraction from contracts, automated clause extraction. Yeah, Kure, you have a doubt?
Yes, sir. So Anand, as you said, right, the accuracy. So what exactly that accuracy uh, level in versus machine learning and deep learning? I believe, as per your statement, the machine learning can get the more accuracy. Is this the right understanding?
No, the point being, machine learning are lightweight algorithms,
Mm-hmm.
right? And deep learning is basically all follow same philosophy. That is, you have arrangement of neurons in different order, right? And you give it an input and you get the output. Now these neurons are heavyweight algorithms or heavyweight process, whereas these one are lightweight process. These strictly work on a formula. They strictly work on formula based. They will basically, this will work on basically weights and biases and everything. Now here, some of these things like random forest and all, they have mixed formula and weights. They will perform better when data is small, complexity is less. They will perform obviously better. But deep learning can also do the same job, but yes, it will use more resources. And as far as accuracy is considered, it all depends on how well the deep learning is implemented. Deep learning, and I have a slide where I have been explaining that it requires more data. That is, let's say if you have 300 points only, deep learning will not work with this 300 points of data. It will at least require 3,000 to 5,000 data. Right? Only then it will start producing results. Whereas this might work with 300 to 500 data. Right? Accuracy, on an average, it can give you a fine accuracy. Right? Now, there is nothing bad around it. But yes, deep learning has, as the data increases, the accuracy of the deep learning increases. Deep learning is able to solve more complex problems. Right? For instance, all of these generation of text, images, videos, there is no chance ML will be able to, traditional ML will be able to solve that. You will need deep learning for that. But the only point I'm trying to bring here, for very small use cases, this old ML still works. It is lightweight and it can give you fine results with that. But yes, I mean, it requires higher amount of skills to implement even these. As compared to deep learning, old ML requires more skills. This new deep learning, I mean, there are a lot of tools available. You can take the models already available and you can train them, you can use them. So yeah, obviously, there are less amount of skills that you require with deep learning.
Okay.
Is it clear, Kyor?
Yeah, it's more clear. Thanks.
Sure.
Anand, so that means deep learning and all these traditional machine learning algorithms, all of this will be basically classified as machine learning?
Ideally, we have started saying it, that's the old ML, but usually it is not that. Even there are some machine learning is any machine that is learning. But yes, I mean, a general non-official terminology, we say that this is ML, this is DL. This is machine learning, this is deep learning. But ideally, as per the definition, we say that even deep learning is part of machine learning itself. So hence, I'm referring it again as a traditional machine learning algorithms.
Okay, yeah, because actually I'm asking because nowadays when you tell people machine learning or deep learning, especially non-technical people, like for example, if you're talking to a customer, and if you tell them machine learning and deep learning, they take a lot of offense to it. And they'll ask you, oh, you're still using machine learning, deep learning. Why are you not using AI?
Oh, right. So both of them are AI.
Exactly. So
Right.
I don't know how do you answer that question, but anyways, yeah, that's why I was asking.
Yeah, so customers are sometimes, they need very fancy and heavy words. Only then they get satisfied.
Correct. Exactly. Yeah.
Right. So in one of the recent scenarios, I was also talking to customer, and when I told them that yes, I can solve this problem, but I will have to customize or I'll have to train this thing. Then they thought, although training was a small training itself, yes, Shelja, that being true. ML is not a subset of DL, but actually AI, ML, DL comes as a subset of ML. So the customer said that, oh, customization and everything, that means you are going to increase my bill and everything. So yes, I mean, customers follow different terminology altogether.
Right. So there is generally I mean, again, just talking at a very genuine language, there is no AI that works from the first day, right? I mean, that is a wrong assumption, right? Some
Yes, that is
customer
a
will
wrong
expect
assumption.
okay, you install this AI model for me, and it should work for me from the very first day by giving me high level of accurate, answers and predictions. That is not that has been my belief also, that is not possible. But customers believe that is possible, and if I tell them
If
that that's
we
not
are,
possible, they think I don't know what I'm talking about. So, but that's not true, right?
yeah, actually, that's not true. Ideally,
Hmm.
let's say if we are simply giving the summarization kind of service and we plug in chat GPT and everything, obviously that can work from
Right,
first day.
right.
But any customized solution will have, it needs some kind of customization and it will take some amount of time.
Correct. Okay. Got it. Okay.
Right. So as we discussed here, so even Peter's uncle said to Peter that, Peter, with great features comes great complexity, and thus deep learning, you know, is complex. Deep learning solves complex problems and it burns money. So traditional machine learning we have, and we have the deep learning, excels with unstructured data. So obviously this is more clear differentiation, that what happens with traditional deep learning, it works with structured data. When the data is properly structured, Excel kind of data, this will work. Lightweight algorithms, right? Complexity, it can handle mid amount of complexity. But then here comes the big deep learning, right? It can handle all Excels with unstructured data, works with images, audios, text, audios. It is able to do something magical, absolutely magical. It learns complex hierarchical patterns, automatically feature learning with the raw data, right? And requires significant data. And this is costly. All of the GPUs, that you see, it is because DL is utilizing that. NVIDIA talking about all of the GPUs and everything, that we require this GPU, we require that GPU. Even a small DeepSeek model took $5 million to train. The whole cost being for the GPUs. I mean, the data was trained on these GPUs. So this being usually, the difference between traditional machine learning and deep learning models.
So
However,
Anand,
the real solution is basically, as we go on, it will take, say, for many of you, this is just 2 days, and you'll have to go through a lot of practical experience when to choose which model. And it's okay to go things wrong also. There's nothing bad into it. This is how you will learn. But as you gain more experience, you will learn to choose, this model is very lightweight for this kind of solution, and this model is very heavy for like this kind of solution. A very simple scenario, one of my customers was recently asked for a feature that I actually run a kind of player league portal, and then I need an intelligence that when there is a match coming up, I should get the best selected players as per the environment and the ground. So in that case, I mean, some of the people suggested him that, use deep learning, use GPUs, you will have to pay this and all those things. Ultimately, the last solution was a traditional machine learning solution that did not even require a GPU. It required some amount of processing forehand, but customer was okay, I can let it run for 1 hour on CPU in the night, and then in the morning when I come, I can have the output. So they solved that problem using traditional machine learning. No GPUs required, all the data on your machine, you don't even need to go to external data. So these kind of problems we have, and as and when you go, as and when you learn, so you'll know about all of these things. So as again, like the middle way is the best path. Sometimes you use machine learning, sometimes you use deep learning. You should not say that every problem should fall into machine learning or every problem should fall into deep learning. Any doubts, team?
So Anand, just a quick question. So if you have a deep learning model which is going to either recognize an image or generate an image, that's typically going to be a very large model, right? Maybe millions of perceptrons in it.
Correct.
That understanding correct?
Right.
With
We will be training image generation model in this in next module, but in this course.
Okay, got it.
Right. So we'll be going through image generation, and video generation is, I mean, we will require a lot of GPU for that. So we'll not be going through that, but text generation will be there. Will be the prompting thing, how this prompting thing works, how all of these conversational agent works. So we'll be understanding all of those things. So by the end of this course, you'll have a thorough understanding of this, how this whole AI world is working. I mean, obviously, in order to get more hands-on, you'll have to sit and run these models yourself.
Okay, fantastic.
Right. Now, I had to make your implementation easy. I have to get everyone started on the models. So basically, what I decided was we will first start with something known as AutoML, a new term introduced again. That is, I'll soon discuss about it. But what does a normal AI machine learning process that is training, what does it include? First is data, right? Obviously. Now this data has to be in matrix, or everyone has been seeing a matrix, that is table Excel format, right? It has to be in this format. It may be image, video, or anything. This is the simplest format, but videos are also in this format, just they are with more complex numbers. That is less of readable to humans. We call it like data transformation and then scaling up of the data. So all of those things, we'll see why it is required. So whenever any concept is required, we will cover that concept only then, rather than covering all of the words concept right now. Right. So first thing is that, let's say we have, as of now, yesterday we did see the housing data. I wanted to cover one more example after this. That is, apart from housing data, real data of, let's say, stocks. The real prediction of stocks. Now, this is not a fake one, a real prediction. But yes, I mean, do not use it in production, right? But yes, it will provide the real prediction, and it is quite accurate, right? Now, we have basically what we want to do with the housing data. We have number of rooms, right? We have area, and we have in whatever society is present, how many, then any other features like on which floor it is, right? What is the age of building, all of these things, and then we try to come up with a tentative price of that house. But what is the tentative price? So yes, going forward, all of this, first we need is data. First point is data, right? And data has to be in this format. There are few ways to arrange the data in this format that we'll look into, right? There are 3 to 4 ways, right? Usually it is, I mean, what we call is arrays, right? Arrays is again that matrix kind of data, 1, 2, 3, 4, 5, 6. That's it. This is the format usually that is followed. Just some different forms of the same array are present, but roughly it is going to be the same thing. Then after that, what is the next thing that we do? The next thing that we do is, once we have the data, our data is present, right, with us, we actually split the data. That is, we will have to train the data. Let's say we have 100 rows in a data, then we will split in train and test. The train is 80% and split is, that's it. Now this is no hard and fast rule. I'm saying it can be 70-30 or anything. You can ideally keep a good amount of data for testing, so that if you have to do that, right? Okay, data is prepared. This is the data we need to train. This is the data we need to test after the training has been done. That's it. Then you need to select the model. Select the model. After selecting the model, you need to select the parameters of the model. Select the params. After you have set parameters, in the sense, how many neurons do you need? How many layers do you need? Right? Neurons, layers do you need? Right? All of these things. And then you need to train the model. Right? All of this process, this whole process, we can automate it. We can automate this whole process. This is what we call as auto ML. In starting, we will use that till the time we don't get well versed with creating models. And then we will start creating our own models. So auto ML, what auto ML does is basically, the cycle of machine learning is data. First, here we have data. Then feature engineering, algorithm selection or model selection, model training and deployment. However, what happens? We just need to come up with the data, let it do all of the job. Let's do testing. This is the part of auto ML. But this is for learning phase. Yes, obviously, even for real-time applications, you can use it. Google Vertex AI is the same thing. I think they're giving the same service in the backend. You just need to give the data. It will automatically come up with the model it needs. It will automatically optimize it, and then you can start your training, and then you're done. Right. Now, any doubts in this? Everyone is clear with this?
This process is for both non-deep learning and deep learning, right?
Ideally, this will be for deep learning only.
Okay.
Right. So this whole course, we will be focusing on deep learning.
Okay.
There is one lecture I can keep on machine learning algorithms. But yeah, because at the end of the day, all of the technologies, even all of the modern technologies, are around deep learning. Hugging Face, the complete, I do not know how many of you know about Hugging Face, but after OpenAI, the next big thing in AI is Hugging Face. Like obviously Anthropic is there, Microsoft is there, but Hugging Face have been doing tremendous amount of job. They're around PyTorch and deep learning. Yeah, Kure.
So Anand, in the deep learning also, if you wanted to choose, okay, my use case is like I wanted to use the auto ML first. So is there any way I can decide, okay, in deep learning, I can go with auto ML, and then I will go further based on my problems and the data and what are the inputs, right? So that way I can choose myself or decide myself. Where exactly I can choose, okay, I wanted to go with auto ML first, and then I will go for more on the deep
Right.
learning.
Now, basically, auto ML is what it is doing. All of this model selection and all. Ideally, how we have been working till now, we have data, right? Then we go on creating our own model, right? We go on creating our own model from scratch, or we use some model that has already been tried and tested, right? And then what I will do is I will train the model. If I'm not getting output, I will go back. I will change parameters again. Parameters in the sense I'll change layers, learning rate, and lot of things we have that we'll discuss in future. And then I'll again test it. And after testing again, now this process alone, sometimes it takes months. This is the whole charm here. No, this is the whole hard work that, okay, this is what it is working, and this is what it is not working. And actually, all of these scientists, big scientists, they are preparing the best architectures of the model. They come up with the best architectures that how it is supposed to perform, and this is what they do day and night. Now, even I going forward, I would also ideally like to do this kind of work, maybe for myself or someone. But yes, there are very few companies that are involved in this. Only the big giants are doing this work. The smaller companies are simply, mostly nowadays, all the AI enabled companies are using ChatGPT wrapper or Anthropic wrapper or any of these wrappers. And hence, if you see any use case that falls beyond them, they will not be able to solve. So, but there, yeah. Yes, Q.
I have a more question, but I will talk more later on this because, for
It's
example,
okay
you said,
if
yeah,
you want to.
Because this topic is relevant. So I feel that if you can allow me that, I can ask. Otherwise, we can discuss more on this because this is a
Sure,
larger.
sure.
Yeah.
You can give your doubt.
Yeah. So in that case, Anand, right? You said that create a model. It's mostly that the big scientists and the team are involved, and it will take definitely more time because it's a
Correct.
very thoroughly analyze the all the like permutation, combination, and other things, right? So, for example, if you create your own model, how we can incorporate with our the other model, or how we can distribute it? Okay, use this model to the outer world, right? So
Yeah,
how?
yeah, yeah. So we call it inference basically. Once we have a model ready,
Mhm.
I have that whole exercise waiting for us, right?
Okay.
Now, let's say we have a model ready, right? Now, this model, we will wrap it into some Flask or something that is an API, right? We will wrap it into an API, just like the normal APIs we have been exposing. And then we say that, okay, you hit this API and you use our model. This is one way. Second way is if you are really distributing in some mobile device or something, you can, even if your model is small, you can ship with your application itself. That is, it will go along with your application. If it is a desktop application or something like that, then it can go along with your application. It can sit in the client system or client mobile phone. Now, this is what Apple has started doing. Right? What they have started doing is, because, I mean, the whole point being, now Apple's model will use the GPU in the customer phone only. So they save a lot of, it doesn't have GPU, phone doesn't have GPU. I mean, the whole compute it is using of the customer phone. In this case, you will have to provide with all of the infra. But ideally for SaaS applications, software as a service, this is what it is preferred.
Got it.
Right?
Yeah.
Cool. Right? Anyone else has any other doubts? All right. So next, we move slowly towards the practical session. Right. And now it's time, basically, we start with a small practical. today I guess everyone has their systems ready, right? So first, what I'm trying to do, I'm very slowly, line by line, we will be seeing that what we are trying to do. And then once we have just achieved everything, then what I can do is you can start writing that code. I have very slowly crafted an application with which you can start, and everything you can understand. Everything, do not hold any of your doubts with you. The second point, this is no real coding. This is simple set of instructions that we are giving to system. You have been doing it since ages. You have been clicking on your systems. You have been giving prompts and everything. So this is not any tougher than that. So I'm very carefully taking you through all of those processes. Right? Clear, team? I'll just share the required file. Give me a second. All right, team. So here I'm very easily starting from the Google. Again, going to our Colab first, right? So first we'll be going is, right? You can just type Google Colab here and you will land here. First, you can actually understand this. And second, what we can do is, once we have already done it, I'll just create a new notebook. Right? So this is my new notebook. I will simply name it that this is my AutoML. Right. Do understand very clearly. I will be making you understand everything step by step. Don't worry about it. And then we also open an online whiteboard. I'll put. So what is the process that we will be doing first? First, let's understand that what we are trying to do here. So first and foremost thing, what we are trying to do, we will be working on this. Let me connect. And the California housing data. So why I'm using this? Because it is easily available, first point. In second use case, which may not be covering if today, because I'll have to make you work on 2 notebooks today, right? So in second session, what we'll be doing, I'll be here live. You will start working on it. Anywhere anyone is getting stuck, I'll be solving that. It's easy, and I'll also be sharing both of these notebooks with you, right? So this is what we'll be doing. For that, first we need to understand what we are doing. Each and everything I will be given in notes to you, right? Everything will be given. You just need to understand first. So what we'll be doing, this is my California housing data. Yeah. It is coming up with certain things. It has 1700 data points, right? 1700 data points. It has latitude, longitude, then what is the median age of house, total number of total rooms. Basically, this data, total bedrooms, what it is doing is it is actually converting this data into a different scale altogether. But yes, we'll ignore this because we'll be loading data from a different source. We'll have population, we have households, we have median income, and all of these things. Although I'm using the same data, but I'll use the raw data so that, I mean, it should not feel like, yeah, Achanak, what did you bring this data from? So this is what we'll be doing. Cool. So first library that we will be actually using here is sklearn, right? sklearn, will be using for making models? No. sklearn we will be basically using for, although it has everything, for playing around, for POCs and everything, right? It has processing, dimensionality, it has classification, regression, all of the things that we discussed. But we'll be not using this because this is typically old ML based algorithms. What we want is, we want basically the new deep learning algorithms. So we will be only using it for loading the data set and dividing between train and test. So here I can write down sklearn for loading data sets and for splitting the data. Good. Right. So it has a simple data set. We go from sklearn dot data sets, import fetch underscore. Now, if you see, it has a lot of data sets, right? It has like OpenML, species distribution, newspaper, California housing is one, right? We need California housing. We'll get this one. And it is now, this Gemini is automatically suggesting that, do you need this one also? I'll go for a tab. Yes, I need, right? And this is automatically suggesting. Right, so it is already done. This time, although you can go ahead and go for generate, but this time I'm not doing, right? There's no harm in generating, but the people who want to appear for interviews after this, for them, this is not recommended, and hence I'm following this step one by one. You will be asked there, although you will never use it, right? But in interviews, you will be asked all of this. They might even ask that where this is present, from where you are taking it. In reality, you will, yes. So 98% or 100% of the data scientists are copying their code from internet and everywhere, and from chat GPT and everywhere. It is okay to do that till the time you understand it, so that if anything goes wrong, you can debug it. Very few people who have been just writing the code again and again remember this, right? So you will be whatever you wanted. Yeah, Cure, just 1 minute, right? So whatever you wanted to be, a good product manager, a good CEO, CTO, whatever it is. By having good functional requirement and using these things, you will be able to do that. For appearing for interviews, even for making projects, you can definitely, there's no harm in generating the Gemini code. There's no harm in it. Just when you're appearing for interviews, they will ask it, although even though they themselves do not use it, but they will ask it. So unfortunately, we'll have to go through it. Yes, Kim.
Yeah, I have a same actually that as you said, right? We need to conceptually know
Yes.
rather than copying from the automated
Correct,
tool.
correct.
So if you can just explain the first one, we all know the fetch California housing,
Correct.
it's a data.
Right.
But what exactly the train test split? If you can just explain wherever you feel that okay, this needs to be explained to the
Sure.
participants. So that's the reason I just heads up to you.
Yeah. So
Thanks.
although as what I tried for this session is that, and even for future sessions, that it should be as simple as and as close to English. Although this is train test split, so basically what it will do is, because let's say I have 1700 records of data, I need some data to test that after my model has been trained, how it is performing on untrained data. That is my real evaluation of the model. So for that purpose, I will need to split the data in two parts, part one, part two. Right. That's it. And then I'll just run it. This is how I run it. Next, I'm also adding comments this time, right? So load the data. As simple as that, loading the data, right? So we go with housing is equal to fetch underscore California underscore housing, I guess, yes. Right. Correct. Just a small thing here that in order to display my data or show to you, I am using this as underscore frame is equal to true. Now I'll come to this. I'm just coming to this, right? Why I did that, right? As underscore frame equal to true will convert data into easily visualize or easily visualizing format, which is called as data frame. Data frame is a kind of virtual table or Excel. I do not take it as literal Excel, but it is kind of table, right? Where we can easily see the data. That's it. I can work it without also, but then it will return me as array, and I will not have labels and everything, right? Let me execute and let me show you what I actually mean. Let's say if I go with housing now, I just print it. This is not human readable, right? Now I can go and right. Sorry. Just a minute. Right. Now first let's have a look at it and then we'll see what it is. So I'm moving very slowly. So we will pause here, we will discuss here, and then we'll follow. You see, this is giving me in very easier format. I can easily see my data. I want to see. It has a tooling here, right? And if I want any kind of visualization, it will automatically do the visualization, right? Okay. And this is how the kind of Excel I get. This is what is data frame. Right? What is important now I'll again go here. Right. So first and foremost thing in data is that first we have data. This is very clear, I guess. We talked about data. Next, data has to be in some format, right? What are those formats? There are limited formats only that are available, right? And let's have a look at those formats. I'll open the PPT here itself. Like, just have a look at this. So here basically what it is, it says that there are usually 90% of the time, there are 4 different data types in which the data is usually present. One it says is list, one is arrays, one is data frame, and one is tensors. Let's understand these 4 things, what they are. Although we'll see them as and when we go. Now, we have seen 2 kinds of data here. One we did see is, right, we know that what is an array. Array is simple matrix. This is matrix. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is array, right? Array can be converted into data frames. Data frame is basically it gives you Excel-like functionality in Python. That's it. That is, you can add a row, you can delete a row, right? You can modify a row. Because now let's say I have these columns here, right? I have C1, C2, C3, C4, C5, and C6, right? I want to delete this column. If I have to do that in array also, I can do that. I'll have to write a program that, okay, this is 0th column, 1 column, 2nd column, go to 1st column and delete this column, right? I can simply like an Excel, I can tell that, hey, I don't need this C2. I can simply go C2 dot delete. So team, the whole point being that Python is plain English, right? So you do not need to be afraid of anything. Whatever we are seeing here, if there is anything, the whole point being there might be certain functions as simple as Excel, right? There might be certain functions that may have different name. We'll discuss them altogether. We come to the point that, okay, we have to convert it into this point. Next, yesterday we talked that, and we'll discuss that again here. Okay. Right. So we have the data here, and process is going to remain same till eternity for deep learning. Data, what do we do with data? We load the data. I was telling you yesterday, this is a big statistical mapper machine. This is a mapper machine. All of you have been like daily using Excels. What mapping machine does, what needs to be mapped, what needs to be mapped to what. This is train data, or we sometimes call it source, target. Train and target. Now, the problem changes here. You see, based on target, our solutioning will change. Just try to understand this. Let's say in one situation, right, I have here I'm trying to predict prices for this location. So my target is going to be price. If I want to find out if this can be my customer fit, then my target is going to be customer fit number. Now, how do you come with customer fit number? Basically, based on this, you'll have to fill up a small, you can use Excel to come up with a small field saying that this is a customer fit 1. Is this a customer fit 0? Is this a customer fit out of 5? Right? Or you can use 1, 2, 3, whatever you wish to. It is completely like flexible. So same data, different solutions. Right? You can modify it as you want, just based on your target data. We can use any target data, any source, any target, any source, any target. And here, all of your questions when you were asking that, you know, can I do this use case or any kind of, you know, so when we were talking about any kind of data that it is not allowed me to write here anyways. So when we were talking about any kind of that, now just imagine when we want to generate images, right? Now let's talk about more examples. How do we come up with image generation now? I have this data of images, let's say. What I tell it, I map it to generate its video. Right? That is, I have images, I have videos of those images, right? So reverse engineering. So I give my model images as input data, and I teach it, you know, what you have to do, you have to generate video. And then we get a model of image to video, right? Then I take one more example. Let's say this time I go with is text, right? So this time I teach now all your LLMs. How do they work? They are question and answering models. What they have done is training data. What it should do is, I have questions and answers both in my training set. I'll say that for this question, you are supposed to answer target changes. Supposed to answer this. For question 1, for this kind of question 2, you're supposed to answer is A2. For this type of question 3, you're supposed to answer is A3. Remember the rule, big mapping. And literally, there are some companies who have gained multi-millions of evaluation by running these models. Multi-millions of evaluation. Astonished team again?
So it is just a database.
Data mapper. A complex data mapper.
Data mapper. But all of this will be stored somewhere, right? So it will just
It
go.
is stored in non-readable numbers format. So basically, it is not exactly database, but it is patterns database, you can say. So what it does is it derives some pattern out of that data and it stores that, not exactly the database,
Oh, okay.
right?
So, okay.
Anand?
Database of neural patterns, basically.
Yes.
Okay.
Yes, Kyo.
Yeah. So as you said that, right? We can call it as a terminology, whatever we can use, the pattern database or something else. So this pattern database deciding while we creating our own LLM, right? Otherwise, if we can take it as in any of the available in the market, this can be already mapping in that LLM, right? As a
Yes.
consumer, we do not require anything, but while creating our own LLM, we need to decide this factor that how we wanted to map those.
Correct.
And it
And let's say for my use case, very frankly, let's say I'm working on a portal, and I am actually on which I want an AI tutor, right? So basically, next, when I have my students, I want my students that when you write a code, my you're writing some code here, and my tutor sits here in every time, and it says that, you know what, you're supposed to do this, you're supposed to write this. If you're doing anything wrong or you're unable to do it, so it will explain. How do I train it? This is how I train it. So this time what I'm trying to do is basically, what is the problem? I also tell you what is the problem that most of these ed tech companies are facing. They are integrating chat GPT. Can this chat GPT, yes, it can do this job, obviously. But now if you just imagine, I'm giving this 1 month free access to everyone, and I have 1,000 students, I'm going to bill, I mean, my bill is going to like shoot like anything, and I'm going to go bankrupt in 3-4 months and shut down of the startup. Right. So then all of these tips and tricks come here. So I might do is I might attach a very small model, but I will train it on like my terms and condition. Now I have a small model, it doesn't burns a hole in my pocket, sorry, and then it does the job. It makes sense?
yeah.
Great. Any more doubts? None? Right. So source and target. Just remember. Okay. Again, going to this source and target thing. Okay, here I am. Right. So here I come. Here I have my data. Now, is this thing clear? This is my source, and this is my target. As simple as that. All I have done is I have just written 3 lines as of now. Is it complex, team? Anyone is not understanding this? I hope this is dead clear.
So Anand, how did you get the? Sorry. So I mean, what I mean is, you've written that second line over there. Y is equal to housing dot target.
Right.
So you're saying that, does this mean that the data frame contains both the source data and the target data?
Yes. I mean, since, see, ideally, all of this thing we will have to do in real time. I mean, when we bring our custom data.
Right.
As of now, we are using, so for the sake of learning, data science community provides us with few of the data sets, because if data sets are not provided, a beginner will not even dare to start. So all of these like community data sets, they have provided a lot of they're present. You can actually go on Kaggle also. You can find lots of free data sets, right? So this is for experimenting and everything. So here, hence I'm using source and target is already available, but not always. When we go with our custom data, this will not be available. In that case, we will have to read from Excel and split it manually, and splitting will be done now also. But then we will have to choose between data and target.
Okay.
In this case, it is already done.
Yeah, got it.
Right? This is for the beginner part. And next part, basically, we will be doing all these things. Right? Okay. And next is, as we discuss, what is splitting the data. We split the data. For splitting, basically, they have a function given to us. Splitting, they have already given a function, right? And that function is called as train test split. It also already gives, and it is actually giving you. You can use the generate function, but I mean, they'll have to, and it is automatically taking your variables also, right? Now, I will have to store this data somewhere, right? So x_train, I'll use some other variables, train by train, and source data for training and source data for test, comma target data for training, comma target data for test. So basically we have two pairs. Earlier what we wanted, here when we see here what we have is source and target. Here what we have is source and target. Now unable to move it. Anyway, so we had is source and target. So basically what happens here is, earlier I had this data set. Earlier I had this data, this was original. This is my rows and columns. This is my target. Two pairs, right? I divide it here into, I will train only 80% of the data, 20% of the data for train and testing I will keep myself. This is target underscore train. This is target underscore test. Similarly, this is source underscore train. This part is source underscore test. This part will be used for testing only. This part I will use for testing. I will not use for train. Is it clear, team? And this here 0.2 says, right? 0.2 is if I get 0.1, so it is 10%. 0.2 is 20%. 0.3 is 30%. Right? How much test size do I? I'll go for 0.2. What is random state? It is simply saying just mix the data together, right? What I'll say is this test underscore size 0.2 means 20%, and then random state means so that everything is not in sequential manner. The whole point being, it doesn't happens that all similar data is sitting together. So I just want that all of the data should mix, different kind of data it should mix. And random state is for randomizing the data. Got it. Done. All right, this also works. Next is basically, I need to actually, I am using here auto keras, right? So AutoKeras is again a framework. I mean, that is for AutoML, right? So I'll be using AutoKeras here. So one thing is very important in ML and why we are using Colabs. Basically, they are confined systems. It is like, all of the different versions of the libraries you install. These are very sensitive. Code is very sensitive to all of that, right? So basically, these are enclosed environments. Even if when you work in your local environment, you will have to create a virtual environment so that if you are doing one experimentation and it fails, you can delete that environment and you can again create a new environment. So your system doesn't get corrupt altogether. So these are just small environments. So I will need to install, right? So it is already, since we use exclamation mark here to install. Scikit-learn is already installed. Pip install is a function that is used to install. Pip is basically a library that installs all other libraries for us. This is the library that we will use for installing everything. Its syntax is as simple as that. In Colab, it's pip and install. So pip install and library name. This is its syntax. Simple commands. So again, I'm repeating that coding is not very tough in AI, but it is more of a hard mindset of experimentation and investigation. This is what is a much tougher part. Coding is easy. We'll just see even when so most of the code is around converting one array to another array and other array to this one. Most of the code will be around that only. So pip install AutoKeras, and then we will also need is TensorFlow, because AutoKeras already uses this library. So I am giving a specific version because I have researched it. I mean, before, so that we don't waste time in the classroom. So I did research it. And you'll have to use the same version for this program at least. Later, you can use different versions. Now, we will be using AutoKeras because we just have to use this. We don't want to use TensorFlow. Right. That's install lib. For some reason it's let it install it. It'll takes just a moment, and we'll have to restart this notebook because some of important changes will be made. So I'll just rerun everything.
Anand, is Jupyter also a good editor for Python?
Jupyter is actually, this is Jupyter notebook only, but it is hosted on cloud.
Okay.
This is Jupyter notebook.
Jupyter notebook, right? Okay.
Yes. You can run Jupyter notebook on your local system the same way. You will have cells, you will have to run everything. That's it.
Correct. Okay.
It is just somewhat advanced version of Jupyter notebook. The
Okay.
whole point being, like, see, AI is not about huge amount of codes and everything. It is about very conscious coding, and hence single lines are very important. And thus we just go on writing line by line by line. These models, some of these models that we see into the production, there are hardly 300, 400 or 500 lines of code. They're not greater than that, but they have valuation in millions and billions, because it is all about that hidden pattern. It is not about the code part.
Hmm. Got it.
Even in our case, I don't think so we'll be going beyond. I guess the maximum will be 100 lines of code at max for some program. That also for mini GPT that we'll be creating. Otherwise, we are not crossing that limit.
Okay.
Let me just rerun it, because I restarted the system. Right, it is done. And now let me just go ahead and install these things. Import auto garage as AK, then import TensorFlow as T. We have a discussion pending today itself on TensorFlow, PyTorch, scikit-learn. What are other libraries that are available for deep learning? So we'll have a look at it. Right, and then I have imported this. Okay, this is some simply import statement, nothing but.
So Anand, the AutoCAD Keras is a open source library for ML use. It's not a
Yes.
part of the TensorFlow, right, framework? Is a
No, it is
separate
not part of
altogether?
the TensorFlow.
Oh, I see.
Reinstall these libraries because this should not be posing the problem. There is some incompatibility it is showing. Just give me a second, guys. Just So team, yeah, I mean, I am facing some issues. I guess I will fix it. In the meanwhile, what we can do is we can start with the first practical, and at least we can reach till here. So this problem is not with the program; it is something with the, uh, you know. In the meanwhile, can we just all of us start with the first program? What I'll do is I'll paste the first Colab program. You can just go to first one and start running the first one. That is the vibe code first model. Now in this, I have also given the prompts, right? So you can follow the prompts, you can write the prompts. I'm sharing this program with you. Write this one. In the meanwhile, I'll fix this one. And as I fix this one, we start with it. The second one also. Right? So I'm sharing this.
Anand, I don't
simply go.
Colab
Sorry?
have my drive.
Pardon?
I don't have this Google Colab in my Google Drive.
Not possible.
Yeah, I went to more, but nope, I don't see
Okay.
it.
So basically, this is why we are here. Let me stop sharing and you can share. I'll finish recording also in the meanwhile. So we'll now troubleshoot all of. Let me first share this in the group, in the chat itself, this program. And if everyone can kindly start doing it.
Can you see my screen?
Yes, I can see.
So I go to new.
More. Oh, how's it? Can you go on Google and type Google Colab?
Yeah, that
But I
works.
think in more connected app, it should be there.
Oh, is it?
Yeah, let's try this way.
Connect more apps.
Okay, let's try from Google itself. Collaboratory. Yes.
This one?
Right. It's there. Install. You can go for install. Okay. In the meanwhile, I will share the data.
Yeah, now I have it.
Cool.
Okay, thanks.
Yeah. If anyone else is facing the problem, please let me know. I'll share the link of the first one. Yeah, it is in the chat. Kindly copy it in your drive. Do not change the same because I'm sharing it from source. So kindly copy it, start connecting. If you face any issues, do let me know.